Hey everybody, in this video I want to go through vertical stretches, compressions, and reflections in the x-axis. So as always, we start out with our parent function, and let's just go ahead and make tick marks. So what we got here is an xy axis. We'll make this 1, we'll make this -1. We'll draw out what we want our parent function to look like, and we have something like that. Okay, that's the graph of y equals sine x approximately. And so what I want is y equals, first of all, I want y equals 2 sine x. Okay, well, all I'm going to do is take my key features, my maximums and minimums in this case, and just double them. So the first maximum at pi over 2 will now be here. First minimum at 3 pi over 2 will now be here. And if you look, every second tick mark is counting as 1 unit, right? So if I have y equals 2 sine x, it's just simply going to be that graph right there. Okay, I've doubled the amplitude. That's y equals 2 sine x. Okay. Next, I might want to draw y equals 1/2 sine x. Okay, so let's write that in. Y equals 1/2 sine x. Okay, now I'm going to just go back to my original parent function. I'm going to have all my key values, and then I'm just going to connect the dots, and I get that. Now I get a graph that has been vertically compressed by a factor of 1/2, whereas my first graph was vertically stretched by a factor of 2. Okay. The next graph I'm going to draw is y equals -3 sine x, and I'll draw that in this color here. Oops, y equals -3 sine x. Okay, so here we have a reflection as well as a vertical stretch by a factor of 3. So I go back to my original graph, y equals sine x, the one in blue, and I'll start out by reflecting it so that I end up with a graph that looks like this. Okay, so that graph right there that I've drawn in the glittery color is y equals -sine x, but then I'm going to triple all of my key values. Okay, and so what happens is this minimum now goes down to here, this maximum now goes up to here, and I'm just going to go ahead and I'm going to connect those dots, and then I'll highlight it just to emphasize it. Okay, and there you go, that's y equals -3 sine x. And then while we're at it, we might as well end off with just one more here. Let's end off with y equals, here, let's do this color, y equals -1/2 sine x. Okay, we take our original blue graph, the pi y equals sine x graph, and we reflect it and cut in half. So we reflect it and we proceed to cut the amplitude in half, and what we get is that green graph. Okay, so that is an example of how we can do vertical stretches and compressions simply by manipulating the a value of the function. Now let's go ahead and let's put a bunch of things together. So let's go down the sheet here and look at a new graph. Okay, so this graph, what I'm going to do is I'm just going to quickly put some tick marks in right here. 1, 2, 3 right there. 1, 2, 3 right here, and 1, 2, 3 right here. Now, this graph, instead, what I've decided is this time I'm going to use the graph of y equals cosine x as my parent function. And for y equals cosine x, what we got to remember is it has a slightly different appearance, doesn't it? Looks like that. That's my parent function, okay? A lot of the same ideas and features, okay, but so that's y equals cos x, y equals cos x, and what we'll do is we'll draw the following graph. Y equals -2 cos x minus pi over 4 minus 1. Okay, now we're going to apply the transformations in the order SRT, stretches and reflections, stretches, compressions, followed by reflections, followed by translations. Okay, so the first thing is that stretch, that vertical stretch by a factor of 2. We're going to do that in a black color. So if you're vertically stretching something by a factor of 2, essentially what's happening is you're doubling your amplitude. So my initial point will now be here. If you double 0, it stays the same. If you double -1, it goes down here. Okay, and what you get for your original transformation, which is your vertical stretch by a factor of 2, is you get that graph right there. Keep in mind that if you don't remember, that's pi over 2, that's pi, that's 3 pi over 2, and that's 2 pi in the graph of y equals cos x, okay? Next thing, of course, is to go ahead and reflect because we have a negative a value. So I'll take my initial point, which is at positive 2, and I'll put it at negative 2. If you reflect something right on the x-axis, it remains. This will go up here. This will stay here. This will go down here, and we're going to reflect now. Okay, so now in red, what I've drawn is y equals -2 cos x. But we're not done. Now what we'll do is we will shift our graph pi over 4 units to the right. Pi over 4 units is half the distance between each tick mark because pi over 4 is 45 degrees and each tick mark is 90. So I'm going to take my original point and I'm going to put a tick there. I'm going to take my place where it crosses the axis, put a tick there. Take my maximum and I am going to put a tick there. I'm going to take my axis point, put a tick there. I'm going to take my end point, put a tick there. I'm going to connect my points, and what I see is a graph that has been shifted. Okay, keeping in mind, of course, now that the minimum at the graph originally starts at now is here. So from this point, I have to go back up again to about here. And I do understand that looks a little bit clumsy there. And let me see if I can fix it up at all, because I know that, okay, that still looks clumsy. So maybe I can go like that. Okay, so it's a little better. But notice it's not getting all the way up to the point where it's 1, because once again, we haven't fulfilled enough space for that to happen, okay? Okay, so now look, now we got to take our final phase of doing this and we've got to move everything down 1 unit. We'll do that in the glitter color here. So this minimum value will now go to here, okay? The axis point, sorry, I messed that one up. That'll go to right here. Okay, 2 units is a tick mark, or 2 grid lines is 1 unit in this graph. The axis point will now go to here, about there, okay, right there. Okay, so let's put that back again and put it right about there. Oops, okay, let's get that out of there. Right about here. This maximum will now be shifted down to here. This will be shifted down to here. This will be shifted down to here. And we're going to go ahead and we're just going to connect those points. See if I can do that again. Connect, connect, connect. Okay. And then it'll once again come back up slightly here at the end. Okay. So something like that. All right. Well, obviously, it's, and I'll highlight it too. Let me highlight it. I always like to highlight my last graph just to emphasize the idea that it is our last one and we got everything we needed to in there. Sometimes you want to double highlight it just so the teacher knows that that's your last graph. And as a teacher, when I'm marking this, all I'm doing is I'm checking on those key points, the axis crossing point, the minimums, the maximums, right? Now, in this case, the actual equation of the axis is at -1 because the graph has been shifted down 1 unit. So I'm looking at those points and saying, is the graph hitting those correct points? If it is, you're good. All right, well, thanks for watching. In the final video in this installment, we'll talk about horizontal stretches and compressions as well as reflections in the y-axis.